All right, advent of code. Catching up here. The last time I did the worst code I've ever written in my life. Not the worst, but it's bad. Um, so this was the box moving one from day 15, and I want to at least go through like how I plan to rewrite it because I do, just not on stream. A lot of times I do my code cleanup sort of elsewhere. I'm basically gonna bomb this and rewrite it. Part one, I'm actually fine with the code I have for it, albeit I'm probably just gonna make this be like a class, all the tracking things, because I think it'll make the code a bit cleaner. But the basic idea is okay. For our robot start position, so we're tracking our robot position, and this is just in Kotlin. As I've mentioned, there's vals and vars. Vals can't change, vars can. All input parameters are vals, and there's actually a really good reason for that. And so this is just the standard var reassignment of that. That is to say, take the value and give me a mutable variable, right? And it's pretty straightforward. Just for like iterate through the directions, get the direction we move. This is I have I have written this because I found it useful. This grid coordinate class has get movement in a cardinal direction, and so this cardinal direction is just up, down, left, right. Um, the way I do my indexing system, just because it's how I'm used to it, is because it makes sense from a standpoint of you just bring in a string and turn it into a grid of cars. Very common thing in AOC. Is just up is actually -1 row, so the 0th row is the top row because that's the 0th line, and then left is going negative in the x direction. Um, except it's a bit weird because instead of this being xy, it's d row d call. I know that looks weird, but it makes sense from sort of how the data is parsed in. Um, that like yes, this you would think that might be the y coordinate, but it's not. It's row column, which and that's just when I think about an indexing system. Like yes, I think x y if I'm doing a graph, but I think about like row column if I'm doing a grid. Probably not right, but it's just it's how my code works. And so the point is, I just have this get movement direction, and then the directions I just map here. So these are reading in the directions up, down, left, right. And so now I'm just, hey, get the to move. That is where I'm trying to move the robot to. If it's empty, well, then we can just swap right away. If it's a box, then we have this push box method. And this push box method and this is where I got into a bit of trouble in part two. It is both a method that checks if the box can be pushed and pushes it if it can. And combining those two things is where I got into trouble in part two because in part two you actually have to look if you're pushing up and down, you have to consider a tree of possibilities. And so anyway, here we have just straightforward like, hey, okay, so we have the box coordinate. So if where we're trying to move is a box, then you know, okay, we try to push the box. So to move being the box's position, well, we're pushing in the same direction on the same grid. And so then we just say, hey, is the thing where the box moves empty? And if it is, and you'll notice there's a little bit of a symmetry here. We're kind of doing the same thing. If it is, we swap. If it's not, then we try to push that box. And the point is, if it's not an empty and it's not a box, that means it's a wall. Just process of elimination, it's a wall. And so because it's a wall, we can't push the box. And so that returns false. And that's why we have this and push box. Because if this returns false, then it cascades down returning false over and over until we hit um, this returns false, which makes this statement false, which returns false, and yada yada yada. Um, until we get back here, and since this is false, we don't move the robot. Otherwise, if we can push the box, and we can push the box that pushes the box, and yada yada yada, then we can move. that part's straightforward. The problem is combining these two things caused the problem in part two, and it's because in part two, and I anticipated this error, but I ran into enough bugs that there was a separation from what I talked about when I got there. This case right here is a bastard. This case. And it's because if we're pushing this box, we can't just check like the box pushes into, because now we have a tree. And we have to check if every leaf on the tree is empty, and only one of them is not empty. And so we have to check all of these. And so the problem is that this box can move, but this box can't. And because this box can't move, I can't push this box to move this box. And so I knew, like, I knew that was coming. And I had it set up where when I pushed this box moved and this one didn't, and this box didn't. And I knew that bug was coming, and so that was where I added my can move approach. There's a horrible, horrible, horrible inefficiency in my can move. And it's that I end up recursing at every level the can move call, and it's structurally I just have to replace it, rewrite it to remove that, to just do a can move check and then a move check if can move is true. But I sort of embedded the logic in the two, and it just wasn't easy to separate while I was writing it. And I didn't want to start from scratch completely while I was writing it. So I'm going to improve that someday. But the code has a very bad inefficiency. It ends up being very slow as a result. But now let's move on. Oh, look, we have another grid problem. Okay, so time again for the Reindeer Olympics. The big event is the Reindeer Maze. Compete for the lowest score. You and your historian arrive to search. Wouldn't hurt. Okay. The Rangers start at S facing east, and they need to reach the end tile. They can move forward one tile at a time, but never into a wall. They can also rotate clockwise and counterclockwise, increasing. Okay, so this is Dijkstra's. This is Dijkstra's. Yeah, this is Dijkstra's. Okay. Um, so this is Dijkstra's, but what I'm going to have to do is have not just one graph, but 4 graphs that include the direction facing, and transitioning between the graphs comes with this 1,000 cost. So, all right, let's get started here. I'm gonna have to remember how to implement Dijkstra's, but I think I have the basics down. Um, do all right. Here's my test input, and same as usual, it's going to be, so this is const val wall, and actually I could reduce this to a graph, I guess. Reduce this to a smaller graph rather than do a flood fill, but a jump graph effectively. Okay, so it's I need to remind myself of, okay, val grid equals grid, and it's going to be lines dot map it dot to car array dot to, and I need to make a grid and a mutable grid. I just have never gotten around to it. So I have my grid. Val start position, so val start equals grid dot coordinates dot single S val end const val empty period. Okay. So from there, I'm just going to pass in grid start end. Actually, okay, I in hindsight, I really should be doing the following, which is I need to start doing this because then I don't need to keep passing grid to all the functions. And in fairness, I should be just using it as a class, but let's do start end. And then it's going to be, okay, so how do we do Dijkstra's? First, I'm going to need a data class node, which is val coordinate, val direction. Oh, and val direction equals cardinal direction dot left. Oh no, cardinal direction right, facing east. Okay, right. Okay. And this is going to be val wait. And welcome to the band list. Sorry, it looked like an ad. And I'm just not really interested in doing ads. Sorry if I misunderstood that. In hindsight, maybe I did misunderstand that. Hang on. Oh, sorry. I misunderstood. That looked so much like an ad. Hang on. Unbanning. Sorry. Sorry. Misunderstood. Very much misunderstood. Can I increase the font size? Yes. Sorry. Maybe. I reserve the right to unincrease it. I'm sorry. That I get a ton of ad spam, and I totally misunderstood the post. I completely and totally misunderstood. I'm very sorry about that. It did look like ad spam for a second. Just the opening of the message. Sorry about that. Very, 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 very sorry about that. Did not mean to ban for asking for a larger font size. I apologize. I just the opening of the message looked like so many ad spam messages I get, and I'm deeply sorry. As soon as I saw the name Closure Guy, I'm like, oh crap, I'm a piece of shit. I'm an asshole. So I am deeply, deeply, deeply sorry about that was not my intent. Very, very sorry. Okay, here I did not mean to ban. I feel like an asshole. Okay. Wait. Let's just do long because I bet the big one is going to be really long. Okay, and then it's going to be const val forward cost equals 1. const val turn cost equals 1000. Okay. Yeah, I want to learn Clojure. I did I learned Lisp when I was in um undergrad. I had a professor who's at NC State now, but he was at WVU at the time, who was really big on Lisp at that point. And so my AI class, we used Lisp, and I definitely didn't get it at the time. Like I didn't get it. I didn't get like what a map was. Mapping a function over a list. Like I didn't get how that was useful because I didn't get the functional side of things. But more and more it stuck with me, and I will say that learning it certainly made me better. I want to learn Clojure. Maybe I'll do Clojure someday, but like I like doing Advent code first in a language that I already know, and Kotlin has become my go-to language for everything. Uh, just because you can write Java-like code, so I can operate in that space, so I just know everything's going on. But then it gives me a chance to sort of practice some of the functional stuff, and then I've quite enjoyed it. Um, so what I'm thinking is so one thing I want to work on is I want to say like, okay, there's no point in turning left or right here. Like there's no point in searching that space. Um, but this should be my node. And so from there, no, I don't want this here because it's going to be val um, best nodes equals mutable map of node to long. So this is going to be like the best nodes that I have. A val visited is going to be my set of nodes. I don't even need this. Oh no, yes I do, because I val queue equals, and it's going to be a priority queue of node. But what's the weight? I'm trying to think how to do this fast. Because here with the priority queue, like I want the weight. But I can get the weight from the map. Okay, yeah, that works. And I'm going to do queue dot add, and it's going to be on node grid coordinates start starting direction. Oh, pardon, direction. Definitely don't want coordinates. So somehow I got coordinate in here, and I don't want that. Grid coordinates. Yes. Okay. There we go. Because that was just all right. So grid coordinate, and then it's going to be add to my priority queue this, and the priority queue is going to be based on Um, wait. I'm trying to remember, is there a constructor for a priority queue in Kotlin that takes in a comparator? Um, oh, right. And I want ascending order, so oh, right. Okay. Well, I can just do um can I not just pass in a comparator? Hang on. I'm drawing an absolute blank here. What am I doing wrong? Let's do weights A minus weights B dot sign. Why why can't I do this? Type mismatch, long, right, but I'm trying to just get the sign of it. Okay. I'm confused as to why this doesn't work. Um that's I'm okay. All right. Let me just turn this into an int real quick and see if am I insane. I'm just trying to figure out if I'm like completely off my rocker. Okay, so that works. But there's no I thought there was like long. So that's a long, right? That's a long dot sign. That was exactly what I typed like 5 minutes ago. It was saying it was compiler. Unless I'm completely off my rocker. So, all right, whatever. While queue is not empty. And then if the queue does empty and we don't find the solution, just throw illegal state exception unreachable. Okay. So now I need to get, I'm trying to remember Dijkstra's off the top of my head. Dijkstra's is, okay. Val next node equals, and it's going to be q.poll, and then my neighbors are val forward node equals, wait, no, if next node dot coordinate equals end, then return, oh, and I need to add right. Okay. If next node dot coordinate, then just return weights next node. And let's turn this into a long. So from there, then it's if next node dot direction, no, next node dot coordinate dot get movement next node dot direction. Equals empty. Oh, this is ugly. I need to like come up with better, shorter names here. So grid.get. Here, let me. Okay. If grid forward is empty, then we're going to add weights. So we're going to do val forward node equals node forward, and then the same direction that we were going in. So next node dot direction, and we're going to do wait, before I have to add the weight. Yes, I have to add the weight before I add it to the queue. That is, I sort of painted myself into a corner there with that. But so weight board node equals weight next node plus 1. Because we're moving forward, that costs 1 or forward cost. Then queue.add forward node. I have to set the weight before I add it to the queue, because otherwise bad things happen. Oh, there's a case I'm not considering here, which is what if I'm already there? Let me actually just say this. Yeah, let's do this right now. So first, if weights dot contains forward node, else Oh, but I'm doing this in a weird way because now I'm gonna have a problem where I'm gonna mess up my priority queue if I do this. I'm trying to remember how Dijkstra's is done, where trying to add the node, but if it's already there, then I need to compare the weights. But now my priority queue is messed up because like somewhere up in the heap I could change a weight and now I have to fix it, and that sort of defeats the whole point of doing a priority queue in the first place, doesn't it? Unless I do something like val visited equals, this is getting ugly though, but val visited that node. Or do I have to worry about this problem? I'm trying to remember. Let me look up my old Dijkstra's implementation from last year because I'm sort of I'm either vastly overthinking it or I'm vastly underthinking it. I can't remember which it is. Um, best weights, previous path. I don't have to worry about that here, I don't think. Right. Okay, this is making sense. This is all. So if the edge is in the previous path, right, we skip it. Otherwise, we do get the coordinates, and then it's new node weight equals the best weights plus the best weight of my current node plus, all right, this was where I do the +1. If best weights contains key, if the best weight contains the key and the best weight is greater than the new node weight, then wait, but what did I do if it didn't contain the key? If best weights or best weights, okay. I did if it doesn't contain the key or does. Okay. Yeah. Right. Okay. I see. Yeah, I was vastly overthinking it. I was getting ahead of myself. Okay. Sorry, that was my Dijkstra's from last year, and from day 17, and so I'm just. All right. So let me do. Right, I'm only going to add it if I'm improving. So, um, yeah, if weights doesn't contain it, or so this would now be Elvis notation. Wait, no, next node definitely has to be there, and or the weights forward node is greater than think this will work out. I'm I think this could lead me to calculate the same node twice, but the solution to that is to just keep track of a visited and then skip visited. I think I'll still be okay here. So then it may lead to some unnecessary keep fixing. So there might be a solution to that. I don't know. Okay, so that's fine, and then I'm just gonna do turn clockwise and counterclockwise. So val turns equal list of grid dot, it's going to be direction, next node dot direction dot clockwise, next node dot direction dot counterclockwise. And then for turn in turns, we're just going to do the same thing. But it's going to be turn node. So it's going to be next node dot direction. No, it's going to be turn is my direction, and then it's turn cost and turn cost. Okay, I think that's the correct implementation of Dijkstra's. Let's find out. I think that's the right direction to go. It's been doing this lately where it keeps removing my imports, and I don't know why. And I need to figure out why it's doing that and turn it off. No such elements. What? Excuse me? Oh. That's why. Index out of bounds. Oh, right. Wait, how can I go out of bounds? But I shouldn't even be able to go out of bounds here. I shouldn't even be able to go out of bounds here. How am I? Okay. Row 15. Wait. What? Why am I trying to go down? And also, it's also, how am I even at? Oh. I see what I did wrong. I was turning at the forward point, not at the unreachable. What? Row 1. Now, what column is this? So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What? But I hit it. Row equals 1. All equals 30. What? Now, let me make sure. Okay, so that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Why am I not hitting that? If weight doesn't contain or is greater than all right, I obviously there's a bug. I'm just confused about what it is, which granted, of course I am, because if I wasn't confused about what the bug is, I wouldn't have a fucking bug, right? I'd have fixed it. Row equals 1, call. Huh? How am I not attempting to turn here? How am I getting up to grid coordinate 112? Okay, so I'm reaching this point. Oh, because it's not empty. E is not empty. Ah, derpy derpy doo. Herp derp. First you gotta herp, and then you derp. And then you win. Yep. I did it right. I just didn't do it right. Okay. All right, how big is my puzzle input? I'm kind of curious. Ooh, that's juicy. That's juicy. I think I did Dijkstra's right. We'll see. Let's change this to input. Take out that print line just to improve the speed a little bit. And continue on to part 2. Now that you know the best path, you can figure out the best spot to sit. Every non... The leaf blowers are like right outside my door. Okay. Every non-wall tile is equipped with places to sit along the edges. While determining which of these tiles will be best spot to sit depends on a whole bunch of other factors. The most important factor is whether the tile is on one of the best paths to the maze. Sit somewhere you'd miss all the action. You determine which tiles are part of any best path, including that. Wait, at least one of the best paths? Are you shitting me? So I'm gonna have to. So there's multiple paths. Okay. So now, this is where I start to hate myself a little bit. So, what I now need to do is I need to find ties for the best path. So I'm going to start with the same Dijkstra's implementation. But now, what I'm going to do, why does it not like this? Why does it not like this? Nobody knows. Oh, long. Okay. So now I need to keep track of the paths within the nodes. So it's going to be path, which is going to be mutable set. Right. Oh, and now I also have to do greater than or equal to? Yeah, greater than or equal to. Um, and it's going to be mutable set of path of start. Hang on, before I start trying to work on part 2, let's just see if we can make this work for now. Let's see if I can just print the path. Q.add forward node, but it's going to be don't want to have that because I do want an exception right. And it's going to be next node dot path plus. Actually, this is just going to be set, not mutable set. Path plus forward. It's going to be var answer equal. Let's do val best path equals mutable set of grid coordinates. No. Best path equals a list of set of coordinate, of grid coordinate. Equals mutable list of, and then var answer. Var best weight equals long dot max value. And then from here I can do if next node dot weight if weight next node is greater than best weight, then break. Actually, let's do it this way. While the queue is not empty and queue dot peak and while weights queue dot peak is less than best weight. Because once the so we can break out a loop then. And it's going to be if the coordinate is n, we instead of returning the weights node, what we're going to do is we're going to do this is now best paths, is we're going to do best paths dot add but it's oh right. That's paths dot add, and it's going to be dot path plus end because we've reached the end. All right, now the end is already included in the path. Next node dot path and best weight equals weights dot weights of the next node, and then continue. I don't want to try to move forward or turn or any nonsense like that. And now we're not returning, but that's okay because we can instead return best weight, but I'm just going to do print line from best paths dot for each print line it. Okay, hang on. Let's change this to break just to make sure I didn't do something to cause problems. Okay, I did something that broke stuff. Because I'm no longer hitting the coordinate. What did I break? Hmm. What did I break? I mean, hashing this set is going to take longer. or doing a quality on set's going to take longer, but none of my paths are so long that I should be just grinding to a halt like this. Okay, I am getting the right result. And there's only one best path in the test input. So I did something to make my efficiency worse. I'll figure out what that is, but in the meantime, let's do no such element. Oh, right. I don't need to replace all the O's here. I'm still only finding one best path. Okay, so it goes up, 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 up until we hit 5. Then it goes over, over, then down, 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 back down to 15, and then over, over, and then up, up. And then we also check up. So somehow we're not catching this turn here as a valid path. Is this where I need to add the greater than or equal to? Okay, I'm still only getting the one path. So I need to make this greater than or equal to. Okay, so that's not the solution because that's really slowing me down and it's not helping. The problem is that I know I'm reaching this point. I know I'm reaching that point at the same score. But my paths are different. So my nodes should be different. So my nodes are different. I think I need to change my approach here. I think I need to turn this into maybe a depth first search. Hmm. Like we update best weight, right? But it's not. It's not always true because best weight should be updated. Also worth noting, I'm getting the wrong answer now. Am I? Have I broken my algorithm? No, I haven't. Okay. But it is a lot slower. So if we reach the end, we update best weight. And then, oh, we don't want to break. We want to continue. Oh, hey, now I'm getting two different paths. Duh. Okay. Right. All right. Okay. But think this is right now. And then okay, this is garbage what I'm about to do, but const val or sorry, var late init var part2 answer equals -1L. I don't know why I thought to do late init there. And then it's just gonna be part2 answer equals best paths dot map it dot oh, it's just flatten actually. Dot flatten dot toSet dot size. I want to be clear. I know that this is garbage, but I don't want to recalculate, and this is the easiest way for me to get there. Okay, so this one was 45, and this one is. Wait, that's not the first example. Oh, in the second okay, did I do the second example here? I think I did. Test input 2. 64. Okay, this is slow, so this is going to be really slow. I don't know how to optimize yet. No idea how long this is going to take. I just have no concept. It's taking a while. I'm tempted to print every like loop just to see sort of how, well, not every loop, but like every 100 loops just to see how much progress we're making. because I want to see if this is feasible in like some amount of time or if I'm just way off. Because I'm worried I'm kind of way off here. But because the issue is there's got to be a lot of paths that are fastest. So I think I just need a different approach here. Maybe I backtrack from the end to the start, and maybe that gives me a better result. Um, hmm. Let's even turn that into 1,000. Um, it seems like I'm revisiting the same things over and over. I feel like here, it's a caching issue that I need to do some type of caching of like if I reach this point, how big is my input again? So it's like 140 by 140 roughly. First, let's just see if we reach the end. So let's do that real quick. Oh, we haven't even reached the end yet. That's weird. So we're not even reaching the end now? Let me try a faster hashing function. We're somehow not even reaching the end now. And before we were reaching the end. Let's just. Yeah. I mean, I think it's just all this equality checking on this path is adding overhead. Man, it's adding a lot of overhead. Like, I'm trying to figure out if that's the culprit here. Let me just see if that's the culprit. That is the culprit. This actually might be a case where it's faster with a list, believe it or not. This might actually be a case where it's faster with a list. Which seems counterintuitive, but I think this is. Actually, I don't even need mutable. I just want list up, right? Forward. It also might be that there's just so many paths because of branching that maybe what I'm even attempting to do with Dijkstra here is just a fool's errand. It might be the case. And actually, let me remove this hash code because that's actually going to make it worse, not better. Hmm. Yeah, I'm just trying to think through this. So like we're getting to here. The point is from here to here is equal cost, and maybe I need to do something with that. Or maybe there's something else wrong with my logic. Let me try something. Hmm, okay. Yeah, I'm confused about why it's saying this will always be false because I'm updating it here. Oh wait, no, I'm not. I know that this code is getting really bad, but I'm trying something to speed it up here. I think this might work. Okay, I think that will work. Let me test it on input test 2. Oh, test input 2. Null pointer at what? Oh. Right. Okay, is 49 the correct answer? No, it's not. But I think I know why it's not the correct answer. And it's because now I actually do need to do this equals. Nope. That was not it. First, let's see how badly I've broken everything. In hindsight, I should have made a commit before I tried going down this path. Okay, so I'm no longer even getting the right answer for the test input. Yeah, so I'm somehow doing even worse now. If it doesn't contain or blah. And if it doesn't contain or blah. Somehow I'm doing way worse now. Oh, wait, I know. Maybe this. Best weight. No, that wouldn't even make sense. Oh, duh. Really stupid. Sorry, I went into programmer brain there. I because those were A. Okay, we're getting the right input there. Okay, let me take this breakout. Let me take this return out. Okay. Yeah, I think I solved the problem. I think it was just that my hashing was taking way too long because I was using the list of coordinates, and I don't actually need to do that. Um, Answer is too high. Too high. How is my answer too high? How am I over counting? I'm adding the path that got me to this point. So I'm at the end. So I've reached the end. And wait. But like that shouldn't be an issue with Dijkstra's because it's a greedy algorithm. What did I try last time? 621? Was that what I had before? Maybe do something like if. But again, this shouldn't be possible. Yeah, it's because it's a greedy algorithm. This shouldn't be possible. Shouldn't be an issue. It's somehow I'm over counting. Test input, I would expect 45. With test input 2, I would expect 64. So with input, I would expect $621. Hmm. I'm somehow overcounting. I'm just getting the coordinates, right? Is there some bizarre edge case I'm not considering? This is frustrating. For grid grid.row indices for each I like how it gives me something and then I hit tab and it's just something completely different. That's such a nice little efficiency boost. Dot call indices dot for each print grid dot get like if my answer were too low, I can actually see how maybe that happens. I'm not understanding how my answer's too high, I guess is what I'm getting at. Gonna be actually if let me do it this way. We're gonna get the grid coordinate, and then we're gonna say if coordinates dot contains grid coordinate print o else print okay, let's take a look at what I'm actually outputting here. And let's look for like something where I deviate or something. Because all right, this path makes sense. This path makes sense, right? Splitting off, joining, joining. Okay, right? Because the point is they all go down. Yeah. Wow, this is just a mess here. But like they're all giving me the same weight. That's what I'm confused by. So I'm getting the same weight from every path, but it's saying my answer is too high. So somehow, like I don't get this is the issue, right? Oh, let me not do. Let's do this. Well, no, but I'm printing best weight and it's not changing. So right, it's long dot max value, and then it's right. So if it's greater than, we obviously update the weight and we add the node. Less than, we don't do that. Like, so I think taking out these equal signs will not give me the right behavior. Like, I think taking out those equal signs is wrong. Yeah, because now I'm only getting 37 and not 49. Right? And like, if I put in this equal sign, wait, does that equal sign maybe not matter? Okay, so I do need both equal signs. I'm just confused. I'm just confused because I can't figure out why my answer is wrong. Like it's right on both test inputs. And I'm getting like the behavior I would expect, but somehow I'm including paths that I shouldn't be. Like we're breaking when we're above best weight. So I'm not. Like this statement shouldn't even matter. Like I shouldn't even need that. So I'm getting 621. I'm still getting 621. Right? So if I've reached the end, then I add my existing path to the best path of of this node, right? I'm not adding some node in direction that I shouldn't be adding. Right. Next turn node. Yeah. I'm just getting the coordinates. So I shouldn't be having duplicate coordinates here. Right? So coordinates dot sort by um like I'm gonna get a ton of printing here, but let me just like triple duper super duper mega check that I'm not getting any duplicates here, right? Am I adding? Yeah. So like this is a list, so it's not mutable, so I'm not mutating it. Maybe it's I'm so stuck here. If weight is less than best weight. This is like my only thought, but this shouldn't even be possible because it's a greedy algorithm. Let me just actually do this. Best path coordinate. Let's change this. Let's change this to just a set of coordinates, and it's a mutable set of. And then I'm just going to do best path coordinates dot clear, best dot add all, Why is it not like this? Oh, because I did this stupid thing again, right? I guess I'm so confused. Wait, this doesn't make sense. No, wait, yes it does, because that's all walled in, right? That's all walled in. There's no alternative path. Okay. If that's all walled in, so I'm looking for my splits. Okay, where did I split off? I split off here. So from this coordinate until they merge. Which they appear to merge here. But like I'm not seeing anything hit a dead end. I'm not I'm passing the test inputs. Right. I guess I'm just confused. Like this if statement shouldn't be possible because Dijkstra's the greedy algorithm and I'm breaking if I hit a weight greater than best weight, right? The issue is that it's very hard for me to evaluate just looking at this graph. So like I'm printing my output here, right? And I'm trying to figure out like I totally get that these 2 points are equidistant. They both turn twice to end up here and here. Like I get that. And then I'm trying to trace backwards. So okay, we have a split here, and we have a split here. Now these though I don't think are equidistant. Hang on. These I don't think are equidistant. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 versus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's not even counting the turns and everything. Just, okay, they both turn once. This turns twice, 3 times. Whereas this turns. I think I see my problem. I think this is my problem. And the problem is that this is the shitty part. So here's the problem is that I'm setting the weight of this. God, this sucks. Let me try something here. I think I know the problem is that these two from here to here definitely should not be equal. 100% should not be equal. Shouldn't be. Like there's no possible way that these two are equal. And I think the issue is that I'm overwriting the old weight, and so it thinks that like when I get here, then I suddenly have the best weight again just because I arrived at this later. And I didn't. Um, and so I think I need to store the weight in the node. I think this is how I have to do it. And maybe I should have done this from the get-go. And it's just a weird quirk where that idea shouldn't have worked, but it just wasn't apparent in the test inputs. And so now my weights are not this. Well, grid coordinate direction, yes, but very specifically, my weight is no longer this, it's forward node dot weight, right? And then so if it doesn't contain it, we want to add. If it does contain it, then we do forward node weight. And so this is now weight plus turn cost. And now this just becomes turn node dot weight and the reason I'm doing this is because now I can add in the following logic. If next node dot weight is greater than weights next node dot coordinates to, so I'm still keeping my weights as this map. These are my best weights, and the point is when I get around to it, when I added it, it may have been the best weight, but then by the time it's actually popped out of the queue, it may no longer be the best weight. And if that's the case, then continue. And this tells me that I wrote my Dijkstra's approach wrong to begin with. Somehow, figure it out later. Okay. 616. There we go. That was it. That was it. Um, that was the problem. So the issue. So to clarify what happened there, I was adding this node to the queue, and the weight that I was adding at was less than the best weight to reach the end, which means I did reach this node, right? Like I did pop this node off the pole because its score was less than like the overall total worst weight, right? Um, so I did pop that off. And it was very specifically like I can tell exactly where it went wrong by looking at it. Because if I look at the same spot in my input again, I bet it won't be there. Where was it? Yeah, here. It was these nodes here were being counted. Yeah, that was the issue. Wow, that was hard. Because the issue is I couldn't just do the hashing of the weight to include the list because that's just too slow. Just like you saw what was happening, it was just too slow, and it's not beneficial. The point is now I know that this is no longer, if no longer a best weight, then stop this path is basically what I'm saying. If someone reached that, but in between the time that I enqueued the value and the time that it comes up, something else enqueued a value at that same destination, same direction with a lower weight. And so yeah. And so like I actually found a section of nodes where I now no longer have that. Okay, let's see how fast I can make this with removing all my prints and extra unnecessary tasks. Um, once just as we get further along, the code gets worse and worse, right? So I no longer need to print grid at the end. Okay, got all my prints out. I mean, the whole thing taking a quarter second, not bad. This is just because I'm not I'm doing both paths at the same time. Like I could get the best path faster in like how fast do I get the best path? Let's just easy way to check is if we've reached the end, return next node dot wait. And wait, it's actually lower? What? What? Apparently doing all those extra paths just doesn't not only doesn't add time, it somehow makes it faster. The fuck? It's times like these I realize I don't understand how computers work. Uh, all right, so that was I'm not going to do another day right now because that burned me out. Day 16, part 1 and 2. All right, I'm going to cut it off there. That took like a long time to figure out that one bug, but I'm still happy. I still have not at any point during this year gone to Reddit, at least before solving it. I may have gone to Reddit after just to see other solutions, see if maybe my solution was inefficient, if I could be improved. But I have solved every problem without Reddit. And for that, I am happy and proud of myself. All right. I'll pick up with 17 and 18 later today, and hopefully actually do 19 tonight. We'll see.